All right. Hello, everyone, and welcome to our ACM Tech Talk today. I'm really glad to have you here. Before we begin, I wanted to start with a somewhat unfortunate announcement. So due to some of the recent events, we've decided as a team that we're going to cancel our remaining events for the rest of the semester. And I know this might be a little bit of a shock, but it really just comes down to resources and time. And we just want to make sure that we can provide you what we can, but with some of these streams, it's become a little bit difficult. So we really want to thank you for your support. And if you have any questions or anything, just reach out to us on Slack. And April Fools, had to get one in somewhere, right? So no, none of that was true. Let's go ahead and continue with the actual announcements. So if you have a question today, just go to Slido. The room code for today is VAIL, V-A-I-L. And if you have any questions throughout the session, go ahead and type them in there. And at the end of the session, we'll do a Q&A and I'll ask some of those questions for you guys. Member dues. So if you haven't paid already and you'd like to become a full-fledged member, just go to acm-utsa.org/join, or you can scan the QR code there. And Slack. I think everybody's part of our Slack channel at this point, but if you're not and you would like to be a part of it, you can pay your dues online and you'll get an invitation automatically, or just email council@acmutsa.org. And we'll go ahead and get you hooked up there. Also, in case you're not familiar with these channels already, we have a few new ones, hackathons, careers, and opportunities. Go ahead and check these out. You'll have to subscribe to them manually. So if you haven't seen these yet, I would definitely recommend checking them out, because we'll post occasionally there to keep you up to date on the cool stuff that's going on. And our social media. So obviously we have a YouTube channel, but we also have an Instagram, Twitter, Facebook, and LinkedIn if you want to connect with us professionally. So I would definitely recommend following us. And some of these links are also provided in the description below this video. And our loyalty program. So if you're not familiar yet, so if you're an ACM member, meaning that you've paid dues, every ACM or ACMW general meeting, workshop, or social that you attend will earn you 1 point. Any major events like Rowdy Hacks from this past weekend or anything else that we announced as a major event is 2 points. At the end of the semester, if you're a non-graduating student, then your membership fee will be waived for next semester. So that's going to be fall 2020. And if you are a graduating senior, you'll get an ACM stole. If you have any questions about some of our ACM goods, like the ACM stoles or your t-shirt, if you haven't received that already and you're a paying member, not to worry, we're going to be collecting mailing addresses from you guys so that we can get that delivered to you. So more information to come on that, so just stay tuned and keep an eye on Slack. Okay, so here's our upcoming events. Number one, Rowdy Creators, Fridays at 10 a.m. This is in the Rowdy Creators Discord. The link is provided below in the description. And ICPC, again, we have a Discord for this one as well. This link is also provided in the description. This is on Saturdays at 10 a.m. And yes, we'll be resuming this week. Okay, so next week, our general meeting is going to be on large-scale system optimization. Dr. Wei Wang will be joining us. He is from the Large-Scale System Optimization Research Lab at UTSA. They deal with things like cloud computing and system software, computer architecture, software engineering. If you're interested in any of these topics, I would definitely recommend checking that out next week. That's Wednesday, April 8th at 1 p.m. here on YouTube. Okay, so without further ado, I want to introduce So Tan and John Perry. They work in the VAIL lab at UTSA, working with artificial intelligence. Really, really cool stuff. So I'm going to go ahead and hand over the screen to you guys. So take it away.
Hello, everyone. Well, to be honest, I believed the announcement that it was going to be canceled for the rest of the semester. That was a nice April Fool, by the way. So that's a good one. So yeah, we are from Vision and AI Lab at UTSA. This is our team. We are the Vision and AI Lab focuses on basic research towards secure deep learning models. So we construct deep theoretical models. It could be like such as preventing against adversarial examples or some of the different cybersecurity approaches, and applying these models in the breadth of like real world applications and technologies. And So we are growing, and we have a number of people that are in the lab. So we have Michael Geyer, David Patrick, Richard Tran, Joshua Green, and this is me, Sothan. I'm a graduate student here at UTSA. I'm completing my master this semester, and so I've been here. I finished my undergrad here as well. I've been here for about 5 years, 5.5 years, and I've been in the lab for about a year. I joined in August of 2019, and I've been working on secure adversarial learning topics. And John, would you like to introduce yourself?
Yeah, hi. So I'm John Perry, also working in VAIL Lab. I've been with VAIL since the beginning, which it came into play around beginning of last summer. My primary research with VAIL is object detection and semantic segmentation. So that's my research focus. Finish up my master's program, I'll probably stick around for that PhD. I also completed my undergrad at UTSA, and aside from that, there's a lot of different opportunities that you might want to keep a lookout for with our lab. A lot of different grants that possibly have opportunities for graduates, undergraduates, and just even if you're not even into research yet, or you're just starting out, there could still be opportunities for you in the future. So keep a lookout for that on our website.
Yeah, thanks, John. So here's our website, cs.utsa.edu, Tilda Fernandez /VAIL. So if you have any questions, feel free to go down the bottom. There will be contact us information. And if you want to reach out to us, feel free to look at the email first. And these are different topics that we cover in our research lab. So first is we have secure adversarial learning. These are like adversarial networks that could be preventing malicious input, as well as creating robust models that can evade like evolving attacks. The second, we have object recognition and segmentation. And this is more like a real world environment. You can detect salient information like objects, cats, dogs, these sort of some computer vision problems that you've seen probably. And John will talk about it more in detail as well. The third area is deep learning for physical sciences. And this is for like reducing time and resources needed for like complex experiments that are usually conducted in the physics world. And these are really exciting and evolving research areas that were at the forefront at the lab. So this is what I've been working on for over the course of a year now, DeepFake Detection. And this is part of the secure adversarial learning research topics in the lab. So more or less, I'm gonna assume that we are somewhat familiar with some of the machine learning and deep learning approaches, and some of you have probably seen deepfake videos. We have some famous ones where there's Obama or for example Mark Zuckerberg, the lip syncing videos and stuff like that. So how are they made, and how do we detect them? So it's becoming these are realistically fake videos and audios, and which are created by using deep neural networks, and they're getting even better, and it's getting easier to generate these sort of videos, audios. So this is what our focus is. We want to be able to detect and be able to tell whether a given video is fake or real. Let's say, for example, you want to upload a video to YouTube or Facebook, right? We have a system where we want to be able to, we would like to have a system where whenever you upload a video, we want to be able to flag it as, well, this is a deep fake, this is not real. But how do we do that, right? We need some background information and what is the research right now. And this is what I've been working on. And there are 3 different methods for deepfake manipulation. The first is face swap, where you have a source image or a video, and then you want to mash it onto the target video and create an output that looks like something that was making it look like the target face is actually the source face, for example. This is a simple approach in a face swap. This is just uh, swapping the face in each frames of the video, more or less, right? And another one is reenactment. Reenactment is as you're saying things, as you're moving your head like it could be like a head puppetry, right? The video will also do the same thing. So we will use a source video, which could be you, and then you wanna maybe use the Obama video as make it say or make it shake its head however you want it to. And deepfakes, the third approach is a combination of face swap, face reenactment. These can be some of the neural texture ones that we've seen are really hard to distinguish from the real or fake. Right? And we have a number of data sets out there in the research community right now. So one of the ones that I've looked at when I first started was face forensics data set. It has a wide variety of videos where it's being defaked with a variety of target and source combinations. And deepfake detection, which is the second one in the list here, was introduced by Google. It was a contribution to the research community and was added to Face Forensics Plus data set as well. The third, we have, these are not a complete list of all the data sets. There are a whole bunch of data sets out there. This is evolving. We're currently working on the research community is evolving and in terms of deepfake research. The data sets for Deepfake Detection Challenge, this is a Facebook organized Deepfake Detection Challenge. They introduced a data set that includes another variety of deepfake videos and somewhat audio deepfake as well for the research community to work and compete against. So in deepfake, the generation pipeline usually works like this. You have a face you start out with, and this is going to be your source image. And then you want to basically, if you look at A and J, A is where you start out with, J is what you want to get out, right? So you want to start out with the original image, which is going to be your source image, and you do the face extraction. You're trying to figure out the landmarks around the face, and we're looking at only the face. If you look at D, this is the face that we're trying to extract from the original video or original source image. And we do this in these following stuff from F to I. This is where we're doing the manipulation of the frame that we extracted. We're converting it into something that we can fit on to and whop it in the target face that we usually have. So in this pipeline, it introduced a lot of, as you can see in the picture E, it introduces a lot of artifacts. That may not be easy to detect with your eyes, but they are clearly, well, sometimes if the video is not very well done, it's very obvious and it's clear to be able to distinguish what they look like. But usually this is what the pipeline looks like and how they get generated from an original face to a fake. When we talk about deepfake videos, they're a collection of just frames. So we start out with just images at first, right? And then we go on to individual frames. Okay. And there are, so this is somewhat preview of deepfake detection that Google introduced by Google AI and Jigsaw data set. And so we have a variety of approaches to for detection methods, right? So the way I categorize is a holistic approach. It just says using holistic as in using the entire image as your input to the detection model. So if you have, let's say in this preview, data set preview, the first, basically these are two images, right, smashed together, but the first image will be, you will include the entire image. That means including the background as well. And so I'm categorizing that as a holistic approach that's looking at the entire image as a collection of input sequence, right? And I put the face, which could also be holistic and maybe another region of interest approach as well. So face forensics one uses a face extraction for classification. So instead of looking at the entire image, it's only going to look at the face. So if I go back here, so the first approach would be looking at picture A, it would feed in the image as the entire image, versus the if you're looking at just the face, then your input to the model would just be like something like D, where you're just looking at the face and around the face region. And another approach is what I call region of interest approach. So that's more detail, and that's domain specific knowledge. So you're using something about the face and feeding that into your model for detection. So let's say eye detection example by Lee et al. They used, this was a very early on deepfake research where they used, basically looking at a potentially a deepfake video, you want to count the number of times. Well, the problem was that a lot of deepfake videos weren't blinking enough, right? So it was really obvious that when the deepfakes videos, you're watching them, it was really obvious they weren't blinking at all because they weren't that good, right? And so this research where it looked at the number of times the person in the video blinks, and over the course of a sequence, right? Sequence of images or frames, right? And determine whether it's a deepfake or not. That was definitely counted again, and we introduced better examples in the deepfake data set, and now they're if you look at the current deepfake videos, they have blinking eyes as well, so they got better. So another example, looking region of interest. I just mentioned eyes, but there are different examples of using facial landmarks. So maybe if you're looking at, let's say, the eyes, nose, teeth, all these different areas individually for the detection mechanism. And this is for the region of interest approach and eyes, and this is particularly my area. And this paper of exposing visual artifacts to expose deepfakes and face manipulation, which shows an examples of how, if you look at these images on here, the eyes, left eye, right eye combination, if you look at them closely, they have really drastic differences. Sometimes they're just reflections, sometimes they're just the iris color even, or it's different, right? So around the eyes, you have the missing geometry. So left eye, right eye differences, the artifacts around the eye. So sometimes you have like strong edges and high contrast spots that are left over when during the generation process. It might be easier if you're looking at the picture below here, where the teeth actually have no gaps in them. So like it's a structureless white blurb. So it's plain white blurb if you look at it here, right? So those are the particular things that we want to look at individually to expose them, because, well, sometimes the deepfake videos may not necessarily be like deepfaked on the entire face. It could just be lip syncing approach. So the third approach that we looked at, if they're just manipulating what they're saying and just the mouth region or the lip region. So we want to be able to look at that area. So the detection model for this case is, it tries to expose those artifacts, like I mentioned above. And basically what it's trying to learn is trying to generalize what normal eyes look like versus what manipulated eyes look like. And be able to tell whenever it sees, okay, this is a normal eye and it does not have a lot of artifacts, or the left eye, right eye don't have a lot of differences between them, right? So, and this is ongoing research as well in the lab. We are growing as well as the numbers, as well as different topics that we're working on. So if you're interested, feel free to like reach out to us, or, first make sure to visit our website and check us out there as well. And I complete this part of the research for eye detection this semester. I'm sure the lab will be looking for a lot of more people to work on this stuff and whatnot. So without further ado, I'm going to pass it on to John. John is going to talk about object detection and segmentation.
Awesome, thank you. So just give me 1 sec to get this going. Okay, so I just want to kind of start off with talking about object detection, segmentation, the problem set, and what that affects. Like, what exactly will that affect in your everyday life and your in common applications? So, most popular that probably everyone knows about is autonomous driving. You know, the Tesla auto drive. This deals with object detection and segmentation substantially, which is actually part of my current research. Another common application is with security, specifically detection for weapons or bombs. TSA uses computer vision for object recognition and segmentation, as well as metropolitan areas like Los Angeles uses it also in their metro systems. Another application, this is actually a snapshot of my my latest research for eye tracking. It's sort of a new hot topic, so not a whole lot done commercially yet, but eye tracking goes into foveated rendering. Super awesome stuff. I'm not going to go super in detail with that, but if you look up that stuff, there's a lot that Oculus and Facebook are doing for that. Some other stuff for everyday software applications. You have your Snapchat, your Pinterest, Facebook, smartphones, everything from Google Smart Lens on Google Pixels to Snapchat for landmark recognition on your face, as well as our postal service uses computer vision for ordering and sorting mail. Military applications go into, I know Sierra Nevada Corporation is doing a lot with this right now, and it's really into drone surveillance and cameras for targeting systems on fighter aircraft. It's ongoing research with Air Force Research, but that's sort of like future stuff that's going to be more application. Currently, medical diagnostics are done heavily with some segmentation, object detection. Everything from CT scans to X-rays will use some form of this. If you look up certain neural networks that have been popularized, like UNet or SegNet, they have a lot into the medical field. Also, for your everyday city life, geosensing is a highly sought after application. This is going into traffic management, your road monitoring, so you can control your traffic lights if your city has real-time traffic monitoring systems. That's sort of something that's ongoing that you're going to sort of see changing from day to day. And agriculture, if you're talking about, you know, there's a weed in the field and you need to get it pulled, you don't really have to do that yourself anymore. That's sort of a autonomous system that's going to sort of apply that and kind of do all the yard work for you. These are all fields of, or these are all applications within this field that have current research and future works to be done. So it's a lot of stuff that you can kind of get into if you're looking at going into this field. Like I said at the start of the slide, that I am focusing my current research into a cityscape data set. It's an urban scenes environment data set. This is a little snapshot from their paper, but this is primarily for obviously autonomous driving. It's heavy task for segmentation. So I'm actually currently working on that literally right now. Not really a whole lot I can show you on this, except to tell you that this is sort of something that's currently ongoing. I know the latest research for this posted this year was from Microsoft Research Asia, and they still had, take this with a grain of salt, an accuracy percentage of 75%. And that's basically looking at all these objects and sort of identifying which pixels belong to what object. And that's sort of like, you can determine your accuracy percentage. With that, 75%, that's still a lot of room to grow. So it's definitely a currently ongoing problem. And just to go into some of my previous research that I did this last year, I went into semantic segmentation for eye tracking. I unfortunately wanted to do a live demo of this. I have an embedded system and eye tracking headset I 3D printed. I was looking at showing you guys that, but that's kind of impossible, given that we're online now. So I just made a little animated picture here of the eye tracking in real time. What needs to happen for eye tracking are things like having a deployable system for embedded systems. Size and complexity matters for this. So basically, one of these problems that you have with doing segmentation object detection is having it be deployable on things like your smartphone. Your smartphone doesn't have thousands of gigs or massive GPUs to do all these computations. So one of the things that you really have to look at is can it fit? Can it fit on my smartphone? Can it fit on my Fitbit? So that's like one thing that you really have to look at. So that kind of goes into it being a real-time application. What good are any of these cool things if it can't really perform on the fly? So that's been an ongoing problem, and this my previous research went into that sort of real-time application where frames per second matter. If you're trying to extrapolate data on the fly, you need something that's really fast. It kind of ties into that size and complexity. So the really cool thing about eye tracking, I touched on it previously, but it's gaze estimation. What does that mean? You have essentially a camera that's recording your eye, and now with computer vision we can predict that eye. What can we extrapolate from that is where you're looking. So then you can get things like, this isn't going to be a good one for most consumers, but hyper ad targeting. But you also have that foveated rendering, where essentially, like, if you're in a virtual environment, you only fully resolve pixels that you look at. So then everything's super, super fast. So the next thing, how you get started with this, or if you're interested in, sort of what it takes. Building the models, building the code is one aspect of it, but applying it is an entirely different thing. So once you get essentially that software working, there's a multitude of steps you need to take in order to make this thing actually work. This little animated picture kind of goes over some of those things. That's a snapshot of my network, but you also have those 3D printed glasses. You have that embedded system. These things are needed for the headset for capturing those images and video. You have the standalone embedded system. That's the NVIDIA Jetson in the picture there. It's used throughout like all the research for this field. There's other embedded systems that just ends up being the popular one. I think it's more of a name brand thing. And obviously you need to have a well-trained neural network. The one I have is a dilated CNN encoder decoder. You can look more into my paper if you wish to. And that kind of brings me to a little bit more about my previous work and also publishing to conference. I just wanted to touch on this a little bit to kind of go into the different side of the research field, and that's gonna essentially be getting that work out there. So this is a snapshot of my paper. I published to ICCV 2019, so that was fall, and that was really hard for me because I had midterms and everything else going on. So I had to fly to Seoul, South Korea, and present there. You can go to our website to check that out if you're interested more into segmentation or eye tracking application, or you can go to the CBF Open Access website. I have the link there for you. I do plan on open sourcing my code. So if you're interested in the code, I will post it on GitHub later this year, and that will sort of give you a solid walkthrough of a model start to finish. And this is a little bit about the conference. The bottom right picture is my poster at ICCV. The top two pictures, I just want to show you how crazy these conferences can get and how many people are interested in this field. Yeah, there was over 7,000 people at this conference, and it was insane. So if you're interested into doing research or interested in this field, it's obviously growing substantially, and there's a lot to talk about. There's a lot of different topics. All right, so that was it from my end. If you guys have any questions.
Yes, actually, we have quite a few in Slido, you guys. So the first one is, how did you guys get started with this research?
So did you want to start with that?
Yeah, sure. I mean, if you're coming in first time, not knowing what that research area is like, and a good opportunity is to maybe start out with independent study, or even director research for graduate students. And I think that kind of gave you an overview of what research looks like. So how I got started was through director research and looking at different areas. And my advisor, Dr. Amanda Fernandez, suggested that I look into deepfakes. Basically, it starts with reading a bunch of papers, a whole bunch of papers, right? What are the different research areas? What is the literature review like? And once you're gonna have a grasp of what the problems are in the research community, it now starts to make sense that what kind of problems that you can craft from that problem. So for example, if I'm looking at deepfake, right, there's a whole bunch of problems, deepfake papers out there, but how do I craft my own specific problem? How do I want to tackle that? Is essentially what you're trying to get at. Right? So how I got started is through director research. Again, you start out with reading a whole bunch of papers. You start with coding a little bit, see some of the examples, tutorials, and it can be very scary at first. Like even finishing a research paper, like do I have to understand everything, every single line, or every single code, or math equations and everything? But it starts small, and if you're interested, there are bunch of research out there, and I mean, this is very new as well, and so the industry is not caught up to this at all. Like there are actual ongoing threats using like fake videos, fake audios even for social engineering at industry level, like mimicking a CEO voice and ordering them to transfer this much amount of money. Like these are real world threats, right? So, but the industry isn't caught up to some of the solutions that we have been seeing in the research community. So it's really exciting, but it's also, you know, you have to start somewhere, right? And so start out with, you know, basic papers, read out what, start with research papers, of course. And yeah, I think at first I didn't think I would be at this level where I'm at, having like, I think I'm very familiar with a lot of the literature out there and whatnot. So I think you have to start somewhere, and I think it helps when you start with a research paper that actually covers all of that. But yeah. John, you want to take it?
Oh yeah. So basically, how I started into this field, I sort of fell into it. I had Dr. Amanda Fernandez for application programming as undergrad, and just sort of, you know, talking with her and kind of getting into her topic of you know, computer vision. I found that you know, it seemed very interesting. So I sort of started doing independent studies with her, started taking classes, and sort of rolled this way. And it seemed to all work out, and it seemed to be something that, you know, I grasped very easily, and it became a good topic for me to research.
Great. All right. So another question for you guys: will deepfakes continue to get better with more research? And if so, do you ever see an end to deepfakes?
What was the last part?
Would you ever see an end to deepfakes?
And deepfakes?
Yeah, like is there any way to completely combat deepfakes so that they no longer exist?
That's a really good question, because like every time we find a loophole in deepfakes, we can use the same, because of the feedback loop we have in generating deepfakes, we can essentially use that back into generating a better model. So in that sense, we will always try to get better at even detecting as well as generating. So it's like you have to play that game where, you know, trying to get better at the against adversaries, and they try to get better at you. But so we're looking at it from one lens of computer vision and using deep learning approaches. There are a number of other approaches that are out there that could potentially, I've looked at some of the approaches that even talk about using blockchains to authenticate videos, but I'm not sure how effective they are or not. But I think just like how we have in cybersecurity, like some of the cybersecurity problems, can you design a system that's always secure? Like that's like 100% secure? I mean, those are like a similar questions. Like it's gonna be, you have to think of it from a system design perspective. So if we're talking about just the research and how do we make this better, if we try to make this better, you know, we can also generate better models, better deepfake generation models, so it gets better at that. But you have to also look at it from the system design perspective of how do we design such a system that, you know, that takes into a number of variables in detecting, not only just detecting, but preventing against these sort of attacks that are out there. So it has to be a holistic approach, is what I want to say. But from just the research area, this is where we're currently at right now, actually. But that's a good question.
Great. So how long do deepfakes typically take to create? And I'm sorry, John, were you going to say something?
Oh, yeah. I'm sorry. Go ahead.
If you have something to say for the last question, please go ahead.
Yeah, for the deepfake perspective is, I mean, you're talking about a generative adversarial network, or GAN. So the GANs It's basically like security for your computer, right? You get security updates and you find loopholes or flaws, and those are exploited, and that is just a perpetual state where it goes from it switches hand from one to the next. And you can kind of see the same thing with GANs. There's things that you can do to protect your systems or protect your own neural net, is creating your own GAN, essentially combating that against your own system, and eventually you kind of close off your system and have it as protected as possible, but it's still vulnerable, and there's always going to be a point of exploit.
Awesome. Thanks, guys. So another question we have is, how long do deepfakes take to create on average? And are skilled users able to create this stuff daily?
I want to say there are even mobile apps out there. I think the face-to-face or face swap application. There's also a GitHub page for that face swap. I want to say, depending on the quality of the videos that you're generating or the resolution taking into account, I've seen some examples where it takes about a couple of hours to about up to 8-16 hours or a couple of days, depending on how long or how length it is. But if you want to say, oh, I want to generate a video the quickest way possible, then you can basically download a mobile app and generate it using that, and it will take you like a couple of hours or even less. So they're very easy to generate. Yeah. John, did you want to add to that? You have any experience?
No, I think you hit it.
Great. All right. So the next question: why is Jetson? Why is Jetson good for AI or neural networks?
You're talking about the Jetson, the NVIDIA embedded system. So why that embedded system specifically for computer vision? Well, it's because of the fact that you can utilize the GPU. Because it's an NVIDIA architecture, most or all, I guess, neural networks that you want to train and utilize GPU, it just makes it faster. With that GPU, you can now have something that will perform a little better in real time. And with NVIDIA Jetson, the TX2, the newest version, has a Pascal GPU. It's just one of the newer architectures. So that is embedded on that system, so you can just utilize that, which is much more beneficial than using just a CPU.
Awesome. So do you want to add anything to that?
No, I think John covered it.
Cool. John, can you tell us more about your experience at ICCV? And did you end up networking with a lot of people in the CV field?
Yeah. So ICCV, it was very interesting. ICCV is a very large conference, considered top tier for computer vision. With that area, it was very overwhelming for the amount of people. And yes, I did network with a lot of people while I was there, and met a lot of different people in not just computer science, but electrical engineering to neuroscience. So it's definitely a multidisciplinary field. Computer vision does hold a lot of that, a lot of like the theory and a lot of the application does come from computer science departments, but it is definitely more than just us. And yeah, as far as that experience there, it's really hard to sort of, at least for me in the conference, it was a little different presenting with subject matter experts, both in industry and academia. The conversations are a little bit different and a little more in depth. And with that, it's definitely rejuvenating being in that type of environment. Definitely with other people that are like-minded and have a lot of the same research. But that's something that, if you ever go to a conference, you definitely be prepared to be a lot of standing, a lot of talking, a lot of walking, and definitely a lot of coffee.
Awesome. Thanks, John. A couple more questions for you guys. So how are the topics picked for your projects, and do you choose them, or does Dr. Fernandez pick them out? How does that typically go?
John, you want to take it first?
Yeah, so I guess my previous research was something that we sort of, with my conversation when I started with the lab, I had a conversation with Dr. Fernandez. I'm sure it's probably going to be similar to you, but we sort of hone in on what interests we have. And, because if you don't have interest in the topic, you're not going to get very far in that research. You're just going to be dead in the water because you don't really care about it. So we sort of found that I found segmentation. I was actually interested just specifically in object detection. I sort of shifted towards segmentation because there was current research in that field. And that sort of led me to that whole thing. And, turned out that was my interest. So I just kind of picked that up and ran with it. I know Dr. Fernandez had this conversation with me. I'm sure most PIs are the same, but it's if you find that you're stuck with that research, or you're just not with it anymore, or you don't care about it, it's really up to you if you want to switch it on the fly. Typically it's not like a good idea, especially like you're a PhD candidate, you go in and you're 2 years in and you're deciding, oh, never mind, I made a mistake, I'm gonna switch hands and go a completely different direction. It usually won't end up well, but it is entirely up to you. And Dr. Fernandez at least would support our decision, whichever way we want to go with that research, if we're not feeling it anymore.
Yeah, I would say a similar experience with John. I came in with a cybersecurity background, so I did my cybersecurity concentration as an undergrad in computer science department. And I came in as, these really cool adversarial examples, inputs. And I think the famous example that was how there's a speed sign, and how do you fool an adversarial model to change a stop, make it look like a stop sign to speed limit of a really insanely high speed limit. So that's kind of inputs how models look at it, and I looked at it from a cybersecurity perspective. And I came in having like basically not a lot of background in computer vision, I would say. I had a couple of classes taken in machine learning topics, but not a lot of classes. So similar experience. I sat down with Dr. Fernandez and we talked about our interest, my interest in the research area, and what are some of the ongoing research that the team is working on. And I really like to be working in teams. So, and then I would say one of the main reason why I joined was because of how smart everybody else is in the room. And I like to be in a room where everybody's freaking smart and I can get to learn, talk about ideas and bounce off ideas from everybody. I would say, this going online doesn't help with that as much. But when I came in, that was really inspiring to work with all these different individuals who are working on different areas of research, but you can talk about your research as well and kind of get into this. So to me, that working in that group environment and getting to work on something that I'm passionate about, and one of the big takeaways is I went to RSA conference this past February, and looking at how this research applies or is being used in the industry or security industry, it opened up my mind, and like what are some of the things that I can work on when I get into the industry, and things that I can look into when I get back to the lab and whatnot. So I would say, it depends on what your interests are. I mean, it definitely has to be, something along the line of our research topics, but there's we're, like I said, we're growing, and we are uh, obviously looking into growing bigger. So yeah.
Great, thanks guys. Another question. So should deepfakes be considered as vulnerabilities?
Well, so depending on what your so depending on what context we're speaking in, right? So let's say you have video streaming or sharing site that you know you, or let's say even social media, for example, right? So if your perspective is our system, our video uploading system needs to prevent, so your threat model would be our social media platform needs to prevent deepfakes video from being uploaded, right? So, and you have this detection model that, you know, that you run whenever a user uploads a video to social media. And if you and an adversary tries to bypass that system, the design, the model, the threat model that you have, then that's a vulnerability in the system that you have, right? That allows the adversary to bypass the system. So from a cybersecurity perspective, yes, based on the context, yes, it could be considered as a vulnerability in the system that we shouldn't allow these deepfakes to get in. But if you're looking at just deepfake videos by itself, they're by design, they're using what's called adversarial machine learning. So there's a whole variety of research out there. And if you're interested, you would start out with maybe GANs and how generation process works. But from a cybersecurity perspective, yeah, you can look at it as a vulnerability through a system that allows people to upload this. So I'm not sure if I answered the question, but that's the way I would look at it.
Yeah, I'm just going to add to that. With deepfakes or GANs in general, it's not necessarily just a vulnerability. Sometimes that's actually an intended process that you want to happen, and you're actually making that to generate. I know Facebook was using this. It was a different aspect of OpenEDS. So my semantic segmentation for eye tracking, there was a flip side to that where they were actually doing eye generation. So to create a more robust data set, they made a GAN to generate more pictures of eyes. There's also a lot of research into GANs for the sole aspect of style transfer learning when you're talking about a model like GAN-GO, where you're actually doing just an art style transfer and you're creating more art from latent space applied to some other picture. So there's a lot of different applications that's not just exploits or vulnerabilities. It's more of just an intended side effect.
Awesome, you guys. And it looks like this might be our last question. John, this one's for you. In terms of approach, did you do anything particular that you think helped you in getting accepted to a high-end conference?
No, not particularly. I basically just went with I mean, when you're doing the research and you're trying to apply to a conference, there's a lot of different things that can take part in that process, and some of that's just the reviewer you get. You might get reviewers that don't really see eye to eye on what you're saying, and they might not interpret what you're trying to put on your paper. So there's a lot into comprehension and what people are reading on your paper. The other side of that is the content itself and the research, and it really depends on what conference, when, and sort of what you're applying for. So when you apply to conferences, you can apply to, just even ICCV. You can apply deep learning in general, segmentation, object detection. There's different, like, I guess, check boxes for your research. And if you apply to one, and let's say 80% of the people applied, they went to that one, then you're going to be more competitive than if you applied to one that didn't really have anybody. They're going to want everyone in those fields, but it really depends on which one they're trying to go after and how many people apply. But aside from that, the content really matters.
Awesome, you guys. Well, I just wanted to pause and thank you so much for being here with us today and talking about this research. Really interesting stuff, and I think that our members will agree based on the amount of questions that we got about it. So really want to thank you guys. As far as like questions, is it all right if anybody has any follow-up questions that they might reach out to you on Slack?
Yeah,
would that be all right?
Slack.
I mean, you can either reach out to me on Discord or Slack. That's fine.
Great. Okay. All right, guys. Again, thank you so much. And thank you, everyone, for watching. We will join you next week.
Yeah. Thank you.
Thank you.